yeah, so I guess I'm just kind of proud of what I've made so far because I am not a electrical engineering educated, engineering at all educated, really much educated at all kind of person. But because of ChatGPT and the world we live in now, I have taught myself, or more like just followed the recipe that ChatGPT has laid out for me with this fun electronics project that I've been working on. So, this is a resistive heater from one of those Walmart fireplace heaters that I used, but I didn't like it very much because I couldn't turn off the stupid lights at night, and they would be cumbersome. Now, I could have just unplugged the lights. I could have just cut the wire, but that is below me. I had to make it more complicated. So, what I wanted to do was turn this thing into an actually thermostat-controlled heater, and I could have done that with a thermostat as well. I could have just replaced the little bimetal guy we've got right here and with something else, and down the road I went. But that wasn't good enough either. So I started thinking, well, if I'm going to want to control this with a thermostat, I could go to the hardware store and I could buy a thermostat for like, $80 or whatever and wire it up. And it might not work anyway because this is a 110 single wire bimetal thermostat, which is basically a physical relay. So really the only way to control it would be with a relay, because thermostats for HVAC units usually run on 24 volt, and this thing runs on 110 for its control signal, right? So I need to get relays anyway, and I was thinking, well, I mean, if I'm going to get relays, I might as well just get a microcontroller and control it that way. And I'm like, well, I could buy an Arduino for $15, or I could buy 3 ESP32s for $14. So then I'm like, okay, well, now it has Wi-Fi and Bluetooth, so I might as well make an app that I can control my heater with. But anyway, I'm getting a little ahead of myself because we're not there yet. But yeah, we've got our little digital temperature and humidity sensor there. And we've got our ESP32, and we've got 3 big solid-state 3.3 volt control signal, 380 volt max output AC Chinese relays that were not too expensive. And right now we're just testing the heater at full bore. So the reason there's 3 is because one's controlling the blower fan, one's controlling the main 2 coils, and then this one's controlling a 3rd coil that when, I guess you would put the switch, put the old switch to the 3rd setting, it would activate this. I'm calling it the auxiliary coil. So yeah, I decided to use 3 because now I can write all kinds of sketches for the ESP that will, reply to all kinds of different conditions inside the temperature and humidity of the room. And I even have a 4th relay, and I might get a 5th, or I might get another pack of 4, because with this relay I could control a dumb humidifier, and the resistive heaters, I don't know if they actually take the humidity out of the air or what the deal is, but they make the air feel awfully dry. So I could run a humidifier to counteract that, also controlled by the ESP32. Yeah, so this is my own little thing, but we put some thermal paste under these guys because they just get so hot, which surprised me. I guess they are kind of at capacity. At least this one is, because the way I wired this up is I noticed that probably a really bad situation would be to be running the coils while the fan's not on. There is a fuse inside here, which I should have taken pictures beforehand, but there's a thermal fuse that seems to respond to a high heat condition if the fan were to stop running or something, and it blasts the hot wire off. Yeah, so I did wire that in, so like the source is coming in here from that fuse inside. So we haven't compromised on safety, not one bit. Can you tell? But yeah, so this relay is allowing power to arrive to the other two relays, so that if the fan's not on, the other two coils can't be on, no matter what's happening on the logic level. So that's another bit of redundancy that I think is important, probably. Yeah, I got lucky because the blower fan is in the back here. It's like a cylindrical blower fan, and this end of the business gets pretty darn hot, and it gets real hot underneath. I'm still not sure how I'm gonna make a stand for this thing. I was gonna 3D print maybe big C-shaped feet so that it cantilevers over its own feet, so that I don't have to have anything holding it up over here so much. But I'm not exactly sure I'm going to handle that. I could just make feet out of steel pipe or something and hose clamp them to the side, but that's not any fun. But yeah, so this end doesn't get so hot, but it also has the blower fan here, so this is kind of like a big heat sink now, and so I mounted the relays to that area of this piece of metal, yeah, I can tell that compared to my previous test, it's warm, but it's not super hot, so that means it's working, because these got so hot that I had them hot glued to the table. I turned this on for about 15 minutes, and it just two of them just melted the glue and started sliding around, and then the other one, this auxiliary one, doesn't get as hot, but this guy gets real hot because he's letting all the current for the entire heater in. So yeah, but I think they're rated for that. I think they're 20 amp, and this is only a 15 amp heater, so should be good. Yeah, so what I want to do now is, where I'm putting this in my bedroom, there's no windows, which sucks, but there is a very long run to get fresh air from outside. It's a 50-foot run, so I have some duct that's already in the ceiling that I stole from a bathroom that doesn't need it, and I want to 3D print a vent fixture that will go on the back, because that's where the main air intake is. There's a little bit of air intake happening here on the sides, but I'm just going to cover them up. They don't get real hot, so that's probably okay. But something else is, once I print this, probably L-shaped, fixture that goes from a square opening to the diameter of the duct. I forget if it's 4 or 6, but 6 inch, 4 inch. I think the thing to do, like, this fan obviously won't be able to create any kind of draw through a 50-foot duct. So I think what I'm going to do is I'm going to get a bigger centrifugal fan and put it real close to the intake of where it comes into the building. And then that way I can create positive pressure inside this duct. Because if I cover these up, it's going to reduce the airflow a little bit. It's going to make it hotter. So probably want a little bit of positive pressure. So that's what the fourth relay will do. The fourth relay will turn on and off that duct fan, but I think another challenge I need to confront is probably it's going to be not enough or too much. It's got 3 settings, right? Whatever vent fan I decide to buy. But probably a better solution would be to have this thing do some PWM control however that's possible, on the vent fan so that it can modulate how much airflow is going to be coming in the back. Because if it's real cold outside, but we still want to get as much fresh air as we can, then we basically want to push as much air through this as will come out at a correct, at a proper temperature, if that makes any sense. So, yeah. Again, like, I don't have any knowledge of this, but this is just kind of like super intriguing to me, playing around with these things. So there's some more cleanup to do, wiring wise, and we need to put in we need to solder in an actual 5-volt power source so that I can run the controller. But yeah, my other idea, which might be kind of insane, I don't really. Okay, so this is a bit of a luxury item, so it's probably not going to happen because it's like kind of unnecessary. But when I'm laying in bed, one thing I hate about smart anything these days is that you have to buy into the ecosystem of whatever the manufacturer of the smart device is that you purchased. And oftentimes it's limiting for no reason. They won't talk to each other. Alexa has problems talking to, Google Home stuff and vice versa, and all kinds of different compatibility issues. But, I guess what I'm doing at this point is I'm trying to make my own smart heater. So, what is the problem is, like, if I'm, well, it's not a problem, but like, if you use something like some service like IFTT, then you can do more stuff in terms of like home automation, but it's still pretty limiting. So what would be better in my mind is, like, what if, hypothetically, I could open up my freaking IDE and blast in a bunch of new code while I'm laying in bed. Like, I'm laying in bed and I'm like, oh, you know what? It's too warm in here because, the moon's out and, like, whatever the stupid reason is, like, it's too cold in here because there's snow blocking the vent entrance and it's reducing the airflow, but we're not compensating for that because, like, we've programmed it in such a way that it doesn't compensate for, like, a blockage of flow or whatever, and I want to put some new code that's going to handle this scenario. Like, smart devices can't do that, at least, like, off-the-shelf ones. But this can, if I have the ability to lay in my bed and run an IDE. Now, I could do that. I could find a way to do that on Android, but it's not very straightforward. So my workaround is, what if I declare a bunch of logic variables that can be like, okay, what, I don't even know what I'm trying to describe. I know there's right words for it, but it might be insanity. There's probably a much easier way to do what I'm trying to do. But, like, okay, so I can't, for all intents and purposes, I can't write any sketches while I'm laying in my bed and upload them to ESP32. I could do an over-the-air update, but I can't put the IDE on my phone in a reasonable way, and I'm not going to get a laptop just to do this. I want to be able to lay in my bed and play with parameters and upload new code to the ESP32 from my phone. That's the goal. So, yes, I know you're very pushy. But the way that I thought this could work is if I, in the code, in the actual sketch, if I declare a bunch of, like, operators, like logical operators, like and if and while, like a bunch of these really simple sort of, I don't know, C++ sort of logical operators, I could then use JSON to manipulate them. So I write like say it like, I declare each of these as variables or whatever they're called, and, the inputs that come in and whatnot. And I also make if a thing that I can use from the JSON, if that makes any sense. See, I don't know. I know if I could do it, it would work, but I don't know if what I'm doing is going to work and if it's the best way to do it. But it would be really cool to just like lay in my bed and use a JSON editor on my phone and like, do these nutty routines with all these crazy conditions in JSON and then upload them with a JSON uploader, which I already got. Well, I didn't get it working. GPT got it working for me. So it's super easy to upload JSONs to a web server, as it turns out. So yeah, I don't know. I wonder what a human thinks about this, because the only thing I talk to when I'm doing any of these projects is an AI, and it's led me down some paths of insanity, which I've noticed that it's really good at like certain things, but at vision and like what the right thing to do given the resources you have, it's not so good at, because it has a limited scope. But that's okay. That's okay. I've learned so much. I've learned so much since I started tinkering with electronics with the assistance of ChatGPT. So yeah. I'm really looking forward to any commentary on this, and you'll get to see what this eventually turns into, when it's getting closer to completion, and when like that, the temperature sensor, I have two more, so I'll probably take one, I'll put it like close in front of the heater so that we can measure the output temperature, and then I'll do one at the intake so we have an intake temperature. And then we'll do one in the room so we have like a room temperature. I think that makes sense. I think. Yeah, I might need more temperature sensors. I don't know. But anyway, all right. Thank you. Bye-bye.